Children, we shall take up the next sum, that is fourth sum in the exercise 2.5. What it says, you see here, ABC is an isosceles triangle right angled at C. Prove that AB square is equal to 2AC square. Children, here you see, according to the statement, the figure is drawn. Here is a triangle ABC in which AC is equal to BC. Because here it is right angled at a C, that means the C should be right angled vertex, that is 90 degree. Clear, children? So if that is the case, A and B are the other two vertices. So A, B, C is a right angled triangle with C is a right angled vertex, in which AC is equal to BC. Clear, children? Because it is isosceles. What do you mean by an isosceles triangle? A triangle in which a pair of sides are equal. In a triangle, if two sides are equal, then it is called isosceles triangle. Okay. So here you see, prove data. In triangle ABC, angle C is equal to 90 degree, and since it is an isosceles triangle, here AC is equal to BC. Clear, children? What is to be shown? We have to show that AB square, that is hypotenuse square, is equal to twice the one of the side square. Twice the side square other than hypotenuse. Clear, children? The proof you see here. In the triangle ABC, angle C is equal to 90 degree. It is given. Okay, that is in the data. So here, since it is a right angled triangle, we can apply Pythagoras theorem. So if you apply Pythagoras theorem here, so what it says, the square on the hypotenuse is equal to sum of the squares of the other two sides. Here hypotenuse is AB, that is AB square is equal to sum of the squares of the other two sides, that is AC square plus BC square. Okay, this we have written according to Pythagoras theorem, that is theorem 2.8. Clear, children? But it is given in the data that AC is equal to BC. So wherever BC is there, can we substitute AC, or wherever AC is there, can we substitute BC, because one and the same, isn't it? So because AC is equal to BC, that is in the data, I am going to replace BC by AC. Clear? Then what happens? The equation becomes AB square is equal to AC square plus, in place of BC, I am replacing AC, then it becomes AC square. So how many AC squares are there, children, here? Here it is 1 AC square, here is another AC square, totally 1 plus 1 is equal to 2 AC square. So we can write this one as AB square is equal to 2 times AC square. Clear, children? So understood? Okay, you take down, children. Children, now you take down the next sum, that is fifth sum. It is exactly the converse of the fourth. Clear, children? Here you see ABC is an isosceles triangle with AC is equal to BC. If the condition is AB square equals 2AC square, prove that ABC is a right triangle or right angled triangle. Clear, children? We have to show that. So here what we have used is Pythagoras theorem, whereas in this we are going to use converse of Pythagoras theorem. What it says in the converse of Pythagoras theorem? if the square of one side is equal to sum of the squares of the other two sides, then the other two sides form a right angle, or square on one side is equal to sum of the squares of the other two sides, then the angle opposite to the first side is right angle. That is converse of Pythagoras theorem. Clear, children? So here you see data, what is given here. According to the statement, the figure is drawn. In this figure, ABC is a triangle. You know where it is given the indication of right angle or 90 degree. It is a simple triangle, isosceles triangle with AC is equal to BC, the condition given here. Clear, children? So in triangle ABC, AC is equal to BC, and also you know that the given condition is AB square is equal to 2 times the AC square. That is given condition. So now what we have to prove, that is we have to prove that if this is the condition, then angle C is 90 degree, or C is the right angled vertex. Clear, children? Okay. So the proof, let us take the condition itself. What is that condition? So AB square is equal to 2AC square is the condition. Okay, this is the condition. So that is 2AC square can split it as AC square plus AC square. That is AB square is equal to 1AC square plus 1AC square. There are 2 AC squares are there, isn't it? But it is isosceles triangle with the AC is equal to BC, the condition, another condition, AC is equal to BC. So in one of the place of this AC, can we substitute BC? Yes. Then what happens, you see, children, the equation, that is, this equation becomes AB square is equal to, I will keep this AC square as such, the first one, plus this AC square I am replacing by BC. Then it becomes BC square. Now you see here, compare this equation with the figure, that is AB square, the square on the first side is equal to sum of the squares of the other two sides. Clear, children? So then what is that converse of Pythagoras theorem states? So according to that, the square on the one side is equal to sum of the squares of the other two sides, then the angle opposite to the first side is right angled vertex. Clear? So by using converse of Pythagoras theorem, we can write it as angle ACB, that is C is the angle that is opposite to the first side. So therefore angle C is equal to 90 degree. Angle ACB equals 90 degree. Since one of the angle is right angle or 90 degree in the given triangle ABC, therefore the given triangle ABC is a right angled triangle. Clear, children? Okay, take down, children. Okay, now we shall take the next sum, that is 6th sum in the exercise. You see, ABC is an equilateral triangle of side 2A units. 2A units. Find each of its altitude. So how many altitudes can be drawn to an equilateral triangle? First of all, what is an equilateral triangle? A triangle in which all sides are equal, all the 3 sides are equal, then it is called as equilateral triangle. One thing you have to remember, equilateral triangle is also an equiangular triangle. Clear, children? Here, ABC is an equilateral triangle. So each side is of length 2 units. 2 units. AB is equal to 2 units, AC is equal to 2 units, and BC is also 2 units. You see, children, here AD is an altitude, means a perpendicular drawn from A to its opposite vertex, perpendicular drawn from the vertex to its opposite side, we call it as altitude. Okay. You see children here, in the triangle ABC, it is an equilateral triangle as it is stated here. AB is equal to BC is equal to CA, that is equal to root 2 unit, 2A units. It is given. Clear? And it is asked altitude, means here it is AD is an altitude drawn from A to the base BC, that is AD perpendicular to BC. Since it is perpendicular, we have drawn, that is angle ADB is equal to angle ADC is equal to 90 degree right angle. So in this case we shall take, so whenever we draw a perpendicular, it has divided the triangle ABC into two triangle. So let us take these two triangle, triangle 1 and triangle 2. We shall compare these two. Is it possible to prove these two triangles are congruent triangle? You see in this, so in triangle ABD and triangle ACD, in triangle ABD and triangle ACD, you see children here, AB is equal to AC, AB is equal to AC, because these two triangle, that is these two sides are the sides of the equilateral triangle. Clear children? So here, therefore AB is equal to AC, the sides of the equilateral triangle. Next, angle ADB is equal to angle ADC, that is equal to 90 degree. ADB is equal to ADC. Okay, and AD is common to both the triangles ABD and ADC. So therefore you see it is a right, that is this is a right hypotenuse and a side, because it is a right angle triangle. ABD and ADC is a right angle, both are right angle triangle. So we can use the Rhs postulate to prove this. Therefore triangle ABD is congruent to triangle ACD. Since these two triangles are congruent, then what happens here? The side BD is equal to DC. BD is equal to DC. Then since it is a 2A units, we can split this 2A as A unit and A unit. That means BD is equal to A units, DC is also A units. Clear children? So that is equal to, they are equal, that is CP, CT, corresponding parts of congruent triangle. Understood children? Now we shall take the triangle ABD. Any one of these two you can take, either you can take ABD or ADC. I have taken ABD. In this triangle, since it is a right angle triangle, that is ABD, so we can apply, that is we can write here, that is angle D is equal to 90 degree. Therefore we can apply Pythagoras theorem, that is by Pythagoras theorem. We can write it as AB square is equal to AD square plus BD square. That is. So what is the length of AB is equal to 2A units, that is 2A whole square is equal to AD. We don't know, that we have to calculate children, but what is the length of BD is equal to A units, that is A square. So apply square to both the 2 and A, then it becomes 2 square is 4A square, that is 4A square is equal to AD we don't know, that we have to calculate, keep it as such, plus A square. Now you send this A square to the left hand side of equals, then what it becomes? So 4A square as such plus a square becomes minus a square is equal to ad square. So I'll reverse this order, then ad square is equal to, after subtracting a square from 4a square, if you take away 1a square from 4a square, you are left with 3a square, children. So ad square is equal to 3a square. Then if you remove square on the left hand side, the right hand side terms will get square root, you know that. Then ad is equal to square root of 3a square. That means that square root of 3 into square root of a square, children. That is root 3a square means that is root 3 into root a square. Clear, children? So that is into. Then here you see, we cannot simplify this root 3 because we don't know the value of root 3. Keep it as such. But here what happens, that is square of a and the root, they get cancelled. What remains after that? A remains. So therefore the length of the altitude AD is equal to root 3 into a, or this can also be written as AD is equal to a into root 3 units. Clear, children? So what is asked here? So we found the length of one altitude. Clear, children? That is a into root 3 units. It is asked to find each of its altitude. So how many altitudes can be drawn in a triangle? There are 3 altitudes can be drawn. Here you see, suppose if it is A, B, C or the vertices, you see we have drawn here AD perpendicular to BC. Similarly, we can draw BC perpendicular to AC. So suppose you just imagine that it is E, and we can draw another one is perpendicular. Here it is. So totally we can draw 3 perpendiculars in a triangle. Since it is an equilateral triangle, so all the altitudes are of equal length. All the altitudes are of equal length. Therefore, the length of, can write similarly, length, that is the length of other 2 altitudes are also that is A into root 3 units. Understood, children? So what is given here? Since we got AD is equal to A into root 3 units, similarly the length of other 2 altitudes are also equal to A into root 3 units. That is, suppose if I draw like this, that is, we found AD is equal to A into root 3, then BE is also A into root 3 units, and CF is also A into root 3 units. Clear, children? Okay, take down. Okay, children. Now, let us start the next sum, that is 7th sum in the exercise 2.5. You see what it says here. Prove that the sum of the squares of the sides of the rhombus is equal to the sum of the squares of its diagonals. Clear, children? So what does it mean? That means if you take the sum of the squares of the sides, you know the properties of rhombus. So it is a quadrilateral in which all sides are equal and opposite angles are equal. Clear? And also the diagonals bisect each other perpendicularly. Diagonals bisect each other perpendicularly. Clear, children? You must remember the properties of rhombus also. Okay? Then it is very easy to prove that. So here I have drawn the figure, that is rhombus according to the statement, and the two diagonals AC and BD are drawn. Here you see, children, here all sides are equal, that is AB is equal to BC is equal to CD is equal to DA, and also as stated in the beginning, the diagonals bisect each other perpendicularly. So bisect means what? They are intersecting at their midpoints. Clear, children? So that means AO is equal to OC, BO is equal to OD, and they are perpendicular to each other. So that means angle AOB is equal to 90 degree, angle BOC is also equal to 90 degree, angle COD is also equal to 90 degree, similarly AOD also. Clear, children? So you must remember all these to prove this. Okay. Here in the data, ABCD is a rhombus. You know that AB is equal to BC is equal to CD is equal to DA. That is, all sides are equal. Next, AC and BD are diagonals. AC and BD are diagonals intersecting at O perpendicularly. So you can write, instead of intersecting, you can write bisecting. Okay? You can write bisecting also. Bisecting at O perpendicularly. Clear, children? Okay. So since they are bisecting, AO is equal to OC, BO is equal to OD. AO is equal to OC, BO is equal to OD. Okay. And perpendicularly means, that is, angle AOB is equal to angle BOC plus that is equal to angle COD is equal to angle AOD is equal to 90 degree. So whenever you find a triangle which is having a right angle, you can apply Pythagoras theorem. So here also, for each triangle you can apply Pythagoras theorem. Clear, children? See here. So first I am considering the triangle AOB. So in the triangle AOB, angle B is equal to 90 degree. Clear, children? So we can apply Pythagoras theorem. According to that, the square on the hypotenuse, that is AB is the hypotenuse here because it is opposite to the right angle vertex. Okay? AB square is equal to AO square plus BO square. So this is by Pythagoras theorem. Let it be equation 1. Okay. Next, children, similarly, in the triangle, in other triangles, that is BOC also, that is BC square is equal to BO square plus OC square. This is in triangle BOC. Clear? Similarly, in triangle COD, you see here, that is CD square is equal to OC square plus OD square. This is in triangle COD. Clear? Next, in the triangle AOD, that is AD square is equal to AO square plus OD square. This is equation 4 in triangle AOD. Clear, children? So, since it is asked the sum of the squares of the sides, here are the AB, BC, CD and AD are the sides of this square rhombus. So, here we shall add all the 4 equations. While adding equations, you have to add the terms which are in the left hand side of equals only, and the terms which are in the right hand side of the equals in the right hand side only. Clear, children? So the terms which are in the left hand side of equals are AB square, BC square, CD square and AD square. I have added here AB square plus BC square plus CD square plus AD square is equal to, next on the right hand side we shall take AO square plus BO square. You see here AO square plus BO square. Next, second equation BO square plus OC square, BO square plus OC square, OC square plus CD OD square, OC square plus OD square, and finally AO square plus OD square. Now in this step you can find there are 2 AO squares are there, there are 2 BO squares are there, 2 OC squares and 2 OD squares are there. We shall add those common terms, that is 2 AO square, 2 BO square, 2 OC square plus 2 OD square. Okay, but here already you know that the diagonals bisect each other. That means AO is equal to OC, BO is equal to OD. Therefore, so keeping the first 2 terms in this equation as such, can we replace OC by AO and OD by BO, because both are equal, isn't it? So I am keeping the first 2 terms, that is 2 AO square plus 2 BO square plus 2. In place of OC I am substituting AO, that is AO square plus, that is 2. In place of OD, that is OD is equal to what? BO, that is BO square. So here also now we can find the common terms, which are those, that is 2 AO square and here it is 2 AO square. Together they make 4 AO square. Clear, children? Similarly, there are 2 BO square and plus 2 BO square. Totally, how many BO squares are there? There are 4 BO squares are there. Clear, children? Now, but here you see, children, here in the diagonal you see, as it is stated here, diagonals bisect each other. That means, you know this AO is equal to OC, AO is equal to OC. So the length of AO and OC with respect to the whole length, that is how they are related to the whole length. So the length of these is equal to half of AC. Understood, children? Similarly, in the case of BO and OD, that is BO is equal to OD is equal to the length of BO and OD with respect to the whole length of BD. With respect to the whole length BD, they are all half of the length of BD. Clear, children? So that's what, in place of AO I am substituting half of AC, in place of BO I am substituting half of BD. But AO is equal to half of AC, BO is equal to half of BD. So in the examination it is no need to write this one. To make you to understand, I have written here, okay. But while writing the notes you could write it down, but during the examination no need to write this. Clear, children? Here so 4, in place of AO I am applying half of AC whole square plus 4 into what is BO is equal to? BO is equal to half of BD. So B half of BD whole square. So keeping 4 in as such, apply square to half of AC, then it becomes AC square divided by 4 plus here keeping 4 as such 1 by 2 BD whole square means 1 by 2 means it is 4, that is BD square by 4 it becomes. Here you see in the numerator and denominator the 4 and 4 they get cancelled. Here also 4 and 4 they get cancelled. Then what happens here? What remained here? AC square plus BD square on the right hand side. What are all in the left hand side? That is AB square plus BC square plus CD square plus AD square. The right hand side after the simplification we got AC square plus BD square. What are those? That is AC square and BD square. AC is nothing but diagonal of the rhombus. BD is also another diagonal. So that means the sum of the squares of all the four sides of a rhombus is equal to sum of the squares of the diagonals. Clear, children? Understood? Okay. Take down, children.